Hello, my name is L Olex, and in this presentation, I will be giving an introduction to TopEx along with the results from the BioCreative VII Track 4 Challenge. TopEx is a natural language processing tool designed to help users quickly explore topics in a set of texts, also known as a corpus. And the best part is no programming or NLP experience is needed. TopEx operates on sentences. The first step in the TopEx pipeline is sentence identification and normalization, where the variability in written text is normalized. For example, contractions are all expanded and all characters are converted to lowercase. The next step in the pipeline is sentence representation. In order for any computer to process textual data, it first has to be converted into a numerical form that incorporates semantics and contextual information. The field of NLP has many ways of doing this that all utilize some type of background corpus that is from the same domain as the text being analyzed. TopEx utilizes the input corpus to create these representations, but it is also customizable to allow use of any other background corpus as well. Most importantly, this step assumes there is only one topic present in each sentence, so each sentence only gets one numerical representation. The third step in the TopEx pipeline is to cluster the sentence representations together to identify groups of sentences that discuss a similar topic. Each cluster is then treated as a single document and run through a traditional topic analysis to highlight keywords and main themes present in each group of sentences. Finally, the results are presented as a scatter plot and word cloud for exploration. Currently, TopEx is best used when you want to find common themes present in a set of texts that are small, such as tweets or blog posts. Current work is being done to improve the TopEx algorithm to run on documents of a larger size, such as long abstracts. For our live demo, we will be exploring COVID-19 tweets from the year 2020. As a use case for the BioCreative VII Challenge, we have already described results from March and December. In March, TopEx focused on ways to stop the spread of COVID, staying home safe, getting tested for COVID, and the media's response to one of then President Trump's tweets. In December, the topic shifted to include the new UK variant, vaccines, and the COVID relief bill. Now let's take a look at Twitter themes from May. In the interest of time, I've preloaded data into the TopEx platform. Here's the main TopEx window. The only thing I did was to click on Upload Docs to Cluster and then click Run Topics. I kept all parameters as default. Here you see TopEx's scatter plot, where each dot represents an individual sentence. We can see some clusters here in the brown, and also another one in magenta, as well as a few others scattered around. You can see on the right-hand side information about each sentence that you're hovering over, including the overall cluster topic. One thing to note with these clusters is this is cluster 18, and it is got the top terms are coronavirus and COVID-19, and cluster 1 as well also has the top term of COVID-19. You can also see this in the word cloud representation for individual clusters. Now, because we already know all of these tweets are about COVID-19, having clusters dominated by these terms is not helpful. So I reran this data in TopEx and input a custom stop words file. This is probably one of the most influential parameters that you can use to influence the clustering results. This stop words file contains words that are uninformative or that we don't want TopEx to consider as topics, including COVID-19 and coronavirus. The one other parameter that I changed from default is the vectorization method. Here we get a completely different set of clusters. Down here in the left-hand corner, we can see this cluster is 19, and the topics are all about testing negative and positive. This dark blue cluster up at the top is about wearing face masks and then President Trump visiting the Ford plant. If we take a look at the word clouds, we can now see that informative words are now dominating these clusters. TopEx has been shown to be useful for more than just the analysis of tweets. Prior to participation in this challenge, TopEx has been used for the analysis of reflective medical writings, discharge summaries, and government communications. As a result of participation in this challenge, several additional use cases have been proposed, including grant summaries, interview transcripts, publications abstracts, and open-ended survey responses. Positive user feedback indicates that the interface is easy to use and intuitive, generally fast at returning results, and the program is good at identifying trends in the data and helping the user to grasp main topics quickly. Areas where TopEx needs improvement are in the error handling of input data that is in the wrong format and additional clarity on how data should be formatted. Additionally, users found the number of customizable parameters good, but asked for more on-site documentation and how best to use them. Finally, those who attempted to upload documents of a larger size did experience long run times. Out of a top score of 5, TopEx scored an average of 3.3 for overall impression. And when asked if users would recommend TopEx for COVID-19 research, TopEx scored an average of 6 out of 10. Participation in the BioCreative Challenge has been very beneficial in providing specific areas in need of improvement in order to give users the best experience possible. Our short-term and most highly requested improvements will include adding more on-site documentation and clarifying the input formats. Specifically, we are looking into supporting native Excel files, as many users may be able to easily get their documents into this type of file format. Longer-term improvements will include algorithm updates to incorporate parallelization to speed up the runtimes on larger documents, adding additional on-screen functionality, like how stop words are input, and supporting different levels of clustering, such as at the paragraph or whole document level. In closing, I'd like to thank VCU's Wright Center informatics team, directed by Dr. Gao, as they were all pivotal in making TopEx what it is today. Evan supports the backend development with assistance from Shri, who also worked on the COVID-19 tweet use case, and Peter built the front-end web interface. Also, Dr. Bridget McInnes from VCU's Computer Science NLP Lab provided a lot of guidance during algorithm development, and the 3CS students who built the first prototype interface for TopEx. Our collaborators, Drs. Diaz-Granados, Santon, Kim, and Tom Newman, have also been pivotal in evaluating the usefulness of TopEx results for various use cases. Finally, I'd like to thank the BioCreative Track4 organizers for organizing this challenge and helping to bring TopEx to a wider user base. If anyone has questions or is interested in using TopEx for their research, please feel free to contact me at alolex@vcu.edu. Thank you.